Colin Walls, and I'm here once again to talk about embedded software. Today I want to think about C++. Now, for many years, C++ has been the language which is going to take over embedded programming, but in fact, C is still the dominant language. But C++ has a few facilities that are particularly interesting in the embedded context, and it's one of those that I want to explore today. And that feature is exception handling. Now, when we hear the word exception, we often think about interrupts, but exception handling is nothing to do with interrupts. It's to do with synchronous events, basically error handling within software. Now, you'll be familiar with the situation. You're deep inside some structure in your program and some kind of exceptional condition, an error or whatever occurs, and you need to deal with that. The problem is, if you're deep inside some structured code, getting out in order to deal with that is a problem. You could use GoTo, but GoTos are not considered a good idea. Or you could have some complex structure that enables conditional variables to take you out of the loop or whatever. Exception handling works around that. It's a very simple idea. What you do is you enclose your code where you want to use exception handling in what's called a try block. Simply the keyword try followed by a block. Inside that block, exception handling will be activated, and you can execute at any point a throw statement. Now again, the keyword throw, and in parentheses after that is an object of a specific type. That is called throwing an exception. That enables you to exit from the code. Somewhere else in your module, you'll have one or more catch blocks. Now, each catch block is associated with a particular type, a particular class. And you may have a large number of these. So when an exception is thrown, a particular catch block will receive it. That enables you to have multiple different exceptions and have different code processing them. And not only does the catch block get selected by the class of the object you've thrown, but of course the value of the object may then be used to characterize the exception further. That's the idea. So it's pretty simple. It enables the code to look neatly structured. There are a couple of downsides though. Embedded programmers are always interested in overheads, and when you use exception handling, you're generating extra code to handle the exception processing. And that code is generated everywhere you compile the code with exception handling activated, whether you're in a try block or not, because the code in a try block may call another function outside of the try block, and therefore that needs to have exception handling activated as well for it to work. This gets a bit worse, unfortunately, because compilers will have a switch enabling you to enable and disable exception handling, but quite a lot of compilers leave it on by default. In other words, you're always generating this overhead code whether you're using exception handling or not. So that's the first thing to check. If you're not using exception handling, make sure you haven't got it switched on. If you want to use it, of course, it's another matter. Now, if you like exception handling but would like to minimize the overhead, there are a couple of little tricks you can use which certainly yield benefits. One of them is to have a single catch block. Instead of having a catch block for each class, with the class name in parentheses after it, you simply put ellipses, ... between the parentheses, and that says, here's a catch block which will catch anything. And it turns out that the code generated is then that little bit simpler. As you might expect it to be, there's less decision making to do. If you want to make it even simpler still, there is a sort of rather untidy looking way of approaching this, but it does work, and that is to have no catch blocks at all. What happens if you throw an exception and there's no catch block? Well, the answer is a library function called terminate is called. Now, normally the terminate function is just a null function, doesn't really do anything, but you can replace it in the library with your own terminate function, which will do whatever you want to do under the circumstances that you've thrown an exception. So there's a couple of possibilities to make exception handling a little bit better in an embedded context. These techniques are not widely used outside embedded because the overheads associated with exception handling are not a big deal on a desktop computer, but embedded programmers tend to be interested in that. So that's it on exception handling for today. I hope you found that useful, and I'll probably be exploring some more C++ topics on future occasions. But for today, that's it. So, bye for now.